Okay, hi everyone, I'm here with your 514 lesson, What if they are greater than 1? Multiplying mixed numbers. In the past few lessons, you worked to extend your understanding of multiplying to find parts of parts. Can this understanding help you multiply any numbers, including fractions, decimals, and mixed numbers? In this lesson, you will investigate this question. As you work with your team, keep the following questions in mind. Can we change the form of a number to make it easier to work with? How can we estimate the size of the product? 529. Jules is a champion long-distance runner. He has measured the length of his route through a park and found that it is 4 3/5 of a mile long. Today he ran his route 2 2/3 times before he had to stop to rest. He wants to know how many miles he ran. Without calculating, estimate approximately how far you think Jules has run. Explain your estimation strategy to your teammates. So go ahead and pause the video and do part A. Remember, it's just an estimation. Okay, if you're back with me, you've done A, so we're going to move on to B. It says draw a generic rectangle and help Jules exactly calculate 2 2/3 times 4 3/5. So I'm going to help you here with our generic rectangles. So again, we want to draw a generic rectangle just like we did way back when. We have 4 3/5. And then we have 2 2/3. So now we need to do our multiplication. 2 times 4 is 8. 4 times 2/3 is 8/3. 2 times 3/5 is 6/5. And 2/3 times 3/5 is 6/15. So now we need to continue on and exactly calculate this. So we have 2 2/3 times 4 3/5, which equals everything in the generic rectangle added together. So we have 8 plus 8/3 plus 6/5 plus 6/15. Obviously, this is going to be 8 over 1 plus 8/3 plus 6/5 plus 6/15. Oh, 8/3. Yeah, that's right. Okay, so now we need our common denominators because we're adding. So 15 is our common denominator. So this, going back to our giant ones, 8 over 1 times 15 over 15 plus 8 over 3 times 3 times 5 gives you 15, which is in your giant 1, plus 6 over 5. 5 times 3 gives you 15, so 3 over 3 goes in your giant 1, plus 6/15. So we have 8 times 15. Let me just double check and make sure. 120 over 15 plus 8 times 5 is 40 over 15 plus 6 times 3 is 18 plus 6 times 15. So now we want to add our numerators all together. So 120 plus 40 plus 18 plus 6 is 184 over 15. Now you want to change this back into a mixed number. So how many times does 15 go into 184? So 184 divided by 15 gives you 12 full times, but we have some left over. So 15 times 12 equals 180. 180 to 184 is 4, so we have 4 miles left over, and our denominator stays the same. So 2 4/15, or I'm sorry, 12 4/15 miles is your final answer. C says compare the exact answer with your prediction. How close did you get? So that everyone's answer is going to be different there. So go ahead and pause the video and answer C. Okay, if you're back with me, you've answered C. We're going to turn to 531. 531. Each batch of Anita's famous bran muffins calls for 3 1/3 cups of bran. Anita wants to make 2 3/4 batches of muffins so that she has enough for everyone in her class. To determine how much she needs to make, she started her calculations by writing 2 3/4 times 3 1/3 and drawing a generic rectangle. A. Work with your team and draw the generic rectangle that Anita may have made. Go ahead and pause the video and draw your generic rectangle. Okay, if you're back with me, you should have drawn your generic rectangle. Your generic rectangle should look like this. And if you write it out, this is what you would have. Okay, so B, B says, Anita is not satisfied. Wait, she says, this rectangle is great for showing me that I need more than 6 cups and less than 12, but I can't tell exactly how much bran to buy without a lot more work. There has to be an easier way. Discuss this with your team. How does Anita know the answer is between 6 and 12 just by looking at the rectangle? Is there a way that you can get an exact answer that is one number without having to find and add 4 products? Be ready to share your ideas with the class. So go ahead and pause and answer part B. Okay, if you're back with me, you've answered part B, so that it's going to be a discussion. So C, write 2 3/4 and 3 1/3 as fractions greater than 1 and then multiply. Does changing the fractions like this make it easier to multiply and get an answer? Why or why not? So fractions greater than 1 is also known as, you might know it, improper fractions. So we have 2 3/4 times 3 1/3. So remember, to make these fractions greater than 1, we need to do 4 times 2, which is 8, plus 3, which is 11. Keep your denominator the same, which is 4. Now we need to do 3 times 3 plus 1. So 3 times 3 is 9, plus 1 is 10. 10 over 3. Now we just need to multiply across, which is 11 times 10 is 110. 4 times 3 is 12. I can simplify this by dividing it by 2. And remember our giant ones. Whatever you do to the top, you have to do to the bottom. So we get 55 over 6 cups. So D, how can Anita determine exactly how much bran to use? Well, we know that she needs 55 over 6 cups. But that's not the easiest thing to do when you're cooking. You can't be like, okay, what's 55 over 55 6 cups? So we need to convert this back into a mixed number. So how many times does 6 go into 55 without having any left over? Well, you could do 55 divided by 6, and it's going to give you a decimal 9.16 repeated. So we know that it goes in 9 full times. That's our big number. So now we need to ask ourselves, okay, what is 6 times 9? What does that get me? How close does that get me? Gets me to 54. And I want 55. So how many does that leave me left over? So I would do 55 minus my numerator, 55, which is my numerator, minus how close I was, which was 54, which would give me 1. So my numerator is 1, and my denominator stays the same. It's 6. So 9 and 1/6 cups is exactly how much bran she would use. This is a little complicated. It's going to take some practice. So we're going to try problem 532. Okay, problem 532. Jessica was still searching for an easier way to multiply 3 1/3 times 2 3/4 from Anita's recipe in problem 531. When she thought of a shortcut, I know, she said, can't we just multiply 3 times 2 and then multiply 1/3 times 3/4 and then just add the results? Consider Jessica's idea with your team as you answer the questions below. What result would you get using Jessica's method? Is this result correct? And B, use your diagram from problem 531 and work with your team to explain to Jessica what she is missing. So go ahead and answer this question, 532. This is going to be something that you do on your own, and then we will discuss this question in class. As always, if you have questions, make sure you email me and ask. Like I said, this is a little more complicated of a topic, so we will continue to practice.